Good morning or good afternoon, everyone, and welcome to today's workshop. Before we get started, I'd like to go over a few items so you know how to participate in today's event. All attendees are in listen-only mode. However, at any point during the presentation, you could submit a question by typing it into the question pane of the control panel. We will collect these questions and address them during Q&A at the end of this presentation. Without further ado, I'd like to introduce Grant Schofield, Director of Infrastructure at Humio. Take it away, Grant.
Thanks, Laura. Hi, everyone. Thanks for coming today. Today, what we're going to discuss is all of the data in AWS. AWS is composed of lots of services, and there's a lot of data that's built into AWS, and they have really good tools to interact with that. But we're going to talk about some alternatives you can do with Humio in order to get even better observability into your system from the data that's coming from AWS. So maybe not all of you are familiar with Humio. So we're going to talk a little bit about Humio in a really basic way, how Humio works and what it does and kind of the flow of data from AWS. We're going to talk about how you actually implement some of the lambdas that we've written ourselves, or maybe use some of the other tools in the community or that the community has built to send data from AWS to Humio. And then we're going to visualize a few different AWS services. Not all of them, but many of the ones that we use day to day. And take a little bit of look at the data, take some look at the queries, and how you can make alerts out of some of this data coming from your various AWS services you utilize. So first, a little bit about Humio. Humio is a log management platform, but it also does metrics. It's not really just relegated to logs. It was built for logs, but at the end of the day, it's a really good time series database that can handle metrics and logs. And distributed tracing as well. We're not going to get into that today, but all of those things fit into the way that Humio works. Humio has a SaaS product, so we have a cloud product with a cloud in Europe and a cloud in the US that you can utilize from your services, or we also do self-hosted. So you can run Humio yourself in your own traditional data center or in your cloud environment. It's built specifically for high volume data sources. When Humio was conceptualized, the backend data storage that the founders originally built was built to handle terabytes of logs a day, and specifically logs. And because of that, we took a little bit of a different approach from some of the other log management platforms. For instance, we don't index the data in a traditional way. We have lots of other really interesting tricks under the hood to make things go fast, but in terms of your traditional searching logs, we're not using index to do that. It's extremely low latency for terabytes of data. So one of the really great advantages of Humio is the really low amount of latency you have from when Humio sees the event when you actually see it in a dashboard or have an alert. You're not waiting for that data to get indexed. So even when you're ingesting tens of terabytes a day, in general, the 99th percentile latency is usually in a few seconds. So traditionally, this is the flow of data into Humio. So if we were to, say, you have an application server, you have your application, and it's writing typically to a log file, and then you're using a data shipper like Vector or a Fluentd to collect those logs and send those to Humio. Humio has a few different interfaces, a few different APIs for ingesting data. We do have an Elasticsearch compatible API, so many of the tools that people may use, like FileBeat, work with Humio as well. And then once it gets to Humio, we parse the data. So if typically most people are sending JSON, so we parse that JSON document and turn that into a data structure we use internally. And so you're able to search for your fields like source IP address equals and things like that. But you're not relegated to just parsing JSON. This is what a simple parser would look like. I'm parsing the JSON, and then I'm telling Humio to use a certain field for a timestamp. And that's generally what you need to do for your JSON. Now you can get more complex parsers. So if we were to look at these, this parser here, we're actually using a regular expression to pull out the fields that we want out of this string of data. So this is, if you, look at it as a user agent, so this is, typical of a HTTP access log or an Nginx access log. So you can get more complex with your parsers as well. But we would always suggest, in the best case, you always send data as JSON. So if we actually look at an actual event coming out of AWS now, this is what one would look like, and this is a guard duty event. We'll discuss guard duty a little bit later, but this is what a typical event looks like coming out of AWS. And from there, we can take these events and we can compose dashboards. So I did this using the guard duty has a feature to generate findings. So I hit generate findings, and we take all those events. There's not really much parsing involved. And then we can create a dashboard, and we'll go into those specifics with guard duty a little bit more later. In addition, you can create alerts. So this alert is looking at the stream of data and is looking at the guard duty data, and anything over a detailed severity of 4, we're going to get alerted on, and we're going to send an alert via PagerDuty. So this is really the query is really simple. We use multiple accounts, so I'm doing a little bit of data massaging and taking our account IDs and giving it a nice pretty label. But really, I'm just counting the detail .severity and how many messages or and what the detail severity was, counting that, and if I have a count over 0, I'm sending a page. So AWS has a large amount of service data, but they come in 3 different forms. There's events, there's traditional logs, and then there are metrics. And there are hundreds of services, and all of them use generally are using logs and metrics. And you get a good amount of metrics for free with most of your services. All of this data is generally going to CloudWatch, although some services can send directly to S3, but there are advantages to using CloudWatch, which we'll talk about in a little bit. In general, when you're getting this data out, in most cases, you're using a serverless-driven architecture. So you're using Lambdas and SQS and SNS and services like that. There's multiple ways to source the same data in many cases. So in the case of CloudTrail or Guard Duty, I could send that data straight to S3. I could send that data to a CloudWatch log stream, which also would get written to S3, or I can create events really easily for Guard Duty, for instance. So I can get that same data from Guard Duty out 3 different ways. So in detail, let's talk about the AWS CloudWatch events. CloudWatch events is sort of the way you automate Lambda in AWS. So you can trigger actions based on certain rule patterns. I could look at the guard duty events and pull out only my production environment and only send an event for that and trigger a Lambda. They can also be scheduled, so you can run one every 1 minute, 5 minutes, 60 minutes, similar to a cron, to actually trigger it. And these are way easier to set up in the UI than they used to be. We do all of ours with Terraform, but it's really easy to configure these in the UI as well. It typically triggers, is going to trigger a Lambda that is either sending the data to Humio, for instance. Perhaps it's adding it to an SQS queue, or it's doing an SNS, which generates an email. It's tightly integrated with other products, such as Guard Duty. So when you're creating an event, there are pull downs, and there are a slew of things that you can choose to pick. Like whenever I get an auto scale in my auto scaling groups, I can send an event, and that event can go somewhere. I can get emailed to tell me that my site is scaling up or something like that. AWS CloudWatch logs, there's service and application logs if you're using a really tightly integrated platform like Elastic Beanstalk or ECS. It's really integrated with CloudWatch logs for your application logs and also service logs. So you can have your CloudFront access logs be on S3 and process those. It's not something we actually do ourselves, but you have that capability. This is where log files go at the end of the day, and this is made up of log streams and log groups. So every application or service is going to belong to a log group, and that log group is a collection of log streams. So the reason why this is, if you're wondering, is because distributed systems are fairly complex. We have data coming maybe from all over the world in the case of CloudWatch. That's getting streamed in, and so there isn't one log file that's always getting appended to. There's various log streams that are getting appended to from the application, and then the way you look at those in Humio is basically from the log group level, and we'll talk a little bit about that later. Services where CloudWatch logs are important: CloudFront, CloudTrail, Route 53, S3, etc. Anything that's really not a metric, where logs provide the context for metrics at the end of the day when we talk about observability. AWS metrics, free metrics abound for most services. Many services offer additional metrics for more costs. So for instance, with Amazon, the managed service for Kafka, you can turn on enhanced metrics, or if you're using AWS bucket replication, if you pay for the service level agreement to guarantee that your bucket replicates within less than 15 minutes across regions, you get additional metrics for replication as well. At the end of the day, these metrics are always there, and you can look at them in the UI for free, but the costs add up, because when you start exporting these metrics, you're paying for the queries that you're actually doing. And you might do different metrics queries depending on exactly how what metrics you're pulling. Custom metrics are available. So if you've been using AWS CloudWatch for a long time, you might be your application may be creating metrics, or you might be processing logs into metrics and creating custom metrics yourself. So these are typical HTTP 200s, 400s. You can create those yourself from your application and have metrics related to your application in CloudWatch as well. So how do you go about sending this data to Humio? Humio, we have two lambdas. Eventually they may get merged. They do slightly different things. CloudWatch to Humio is for sending logs and metrics. Humio AWS Lambdas handles events, so that's how we move guard duty data right now, but it's also kind of a test platform. And so there's some early work going on around processing data from Kinesis, for instance. So it's handling streaming and events, and CloudWatch Humio handles logs and metrics. And we ourselves use Prometheus CloudWatch Exporter for metrics. I'm not going to go really into the configuration of too many of these, at least the Prometheus CloudWatch Exporter, but we are going to look at data that it is producing. So CloudWatch to Humio is really easy to get going. I can show a little bit of a demo real fast. So if I want to launch the Lambda, let's launch it in US West Oregon. So when it comes up, I get my typical screen. I hit next, and we have two clouds. Cloud.humio.com is in EU. I could send this to cloud.us.humio.com, and then I put in my ingest token. From there, if I'm going to be a good teammate, and tag my resources. And then from there, there's a few parameters you can change. So this tool actually has the ability to backfill logs as well, and the documentation goes into that. But from there, I create my stack. Oh, I didn't say yes. I acknowledge that AWS is going to charge me for this. And off my stack goes. So creating that setup. So we're going to look at some of the data from CloudWatch to Humio. Like I said, it's a Lambda. It has simple configuration. I just put in my Humio URL. I put in my Humio ingest API token. It is a beta application, so one of the things that we need to add to it is the ability to pull your Humio ingest API token from KMS. The other Lambda supports that. So there are enhancements we need to do there. And we'd love to hear feedback, especially around the metrics, because the metrics was just added. The way that CloudWatch to Humio works for logs is it's reading logs from S3 and writes those events to Humio. the way that it knows that new log groups exist is by listening to CloudTrail events. So when a new log group is created, it will notice that and start monitoring those log streams created by that log group. Like I said, it is capable of backfilling older logs, and documentation covers that. CloudWatch Humio for metrics. There's 2 metrics for reading data. There's the metric, CloudWatch metric ingester and the metrics statistics ingester. The difference between these two these are the 2 different API calls that are available for get metric data. The CloudWatch metric ingester can ingest a ton of events, can ask about a ton of events. So that's generally one that you're going to be running maybe every minute. The metric statistics ingester takes one event and gets you all of the data across a certain time set. So depending on how you want to query your data, you may use one versus the other. You should generate your config based on the metrics you want to send to Humio. We could go into the Lambda and edit the config file and things like that, but generally you want to generate that. And then to trigger it every minute, every 5 minutes, you would trigger it with a CloudWatch schedule event bridge. Humio AWS Lambda is what we use for events right now. It's triggered from the rules from a CloudWatch event rule based on guard duty. But you can also use it for any other of these AWS events like CloudTrail events, auto-scaling events, etc. What we use in our environment in AWS today to get a vast majority of our metrics is the Prometheus CloudWatch exporter. And so what the Prometheus CloudWatch exporter does is it's actually a Java process that's running, and you give it a config file that says get data about these AWS metrics. Because we run Kubernetes internally ourselves, we already have a good amount of Prometheus things going on, and then we set up pods to scrape that data. We currently use MetricBeat, going to move to Vector to scrape the Prometheus data and write that data to Humio. So visualizing the AWS services with Humio. Now that we've talked a little bit about Humio and how Humio works, we're going to actually take a look at some of the data coming out of Humio, or that's in Humio for AWS. So this is kind of an ad hoc dashboard I just made. I hadn't looked at the CloudTrail data extensively. So I just started exploring it and started playing with the data. And so just one of my initial things that I saw that was interesting. There's this user agent going on, and there's a few events that I'm grouping by event name and getting the region and then counting that. And so what I found by looking at this is the vast majority of the things going on in this test environment, or in this account that I was looking at, are generally automated things going on inside our Kubernetes cluster. Auto scaling and things like that. So this is an interesting view. If you were having maybe an issue or something unexpected happening, I could look at all the events going on in my CloudTrail and see what's interesting there. So we can take that idea and produce a really basic dashboard really fast. I did do a little magic to hide my IP address and hide Mike's IP address, but these are logins into our sandbox account. In particular, in the sandbox account, and pulling out all the user logins out of CloudTrail. So these are the console logins. There's service events, event types, the event counts that I just showed. And then the last one, I think the last pane is interesting. I can actually see the API calls being made against a specific bucket. If you have a really bucket-driven workflow in your environment, this may be useful just to see what's going on a given bucket. And all that data is available via CloudTrail. The way we're getting the CloudTrail data is actually by creating a CloudTrail stream in CloudWatch logs. A CloudWatch logs group is being created, and then CloudWatch to Humio is monitoring that data and sending it to Humio. So when we talk, so that was more log data, CloudTrail data. This is actually event data. So for our cloud environment, we actually utilize AWS's load balancers. And this is the important thing about these integrations, is that when you start using a cloud like Amazon or Microsoft Azure or GCP, you have all of these services that are helping you make your app scalable, but you need that metric data as well. And so when we're running Humio, we monitor Humio with Humio, but we're pulling on this data from all of the rest of the ecosystem. And because we're using network load balancers, this data is really important for us to see. And so we'll see in the end how we tie all of this data together into one view. So this AWS data, as well as the Humio data. So if we're actually looking at this data, as I said, we're pulling this data with the Prometheus collector. This is what this actual query looks like to produce my NLB healthy node count. In general, the approaches are the same. What's going to change is your labels and your, I guess the names of things. But really, the important line is the last line in this query, that time chart. It's taking, it's looking at the availability zones and then it's averaging the healthy count across that. So this is a place where we would also create an alert. So if our healthy host count is below 3, this is a small cluster of 3 nodes, then I would page. Our production cluster, of course, is larger, but we do generally want to know when one of the nodes is down, and we can look at that from the NLB view, not just we're looking at it from the Amazon services view, which is really important in terms of uptime and things like that. Mostly because you need to look at the entire life cycle of the request and monitor that. So what's going on at the NLB and what the load balancer sees is important, and it's vital that you monitor that. A little bit about guard duty. Guard duty, I've been, I think it's a really impressive service overall, and it's super cheap. It gives you really, really great information about external threats, internal weirdness, and things like that. So these are generated events in our environment just to show you what they look like, but there's a ton of data available here that might that's really valuable to have, but not always necessarily in your dashboard, visually. Maybe I want to see that data when I'm digging into an incident, but it's right here we're taking a really high level view and gathering up this data, similar to what we showed earlier. So how do we actually take those guard duty events and make it into this dashboard? It's basically this process. So these are the queries for the top 2 boxes that you see there. I'm looking at the detail severity. So in guard duty parlance, that's anything above, that's 7 or above, and I'm counting that. And then here what I'm doing in the query on the right is I'm doing the same detailed severity, but I'm dressing up the data a little bit. I'm taking the account IDs that we have there and actually switching with the account IDs that we have. And then I'm making a table that has the account, the region, the severity, and the detail, title, and description. So once I do that, it comes up into this pretty dashboard. So that's useful and great to have a dashboard, but really I need the alert too. So this is what what our guard duty alert pretty much looks like. Is anything above a detail severity 4, count it. That count is above 0, page someone, wake someone up, because especially on the high severity side, something generally shouldn't do that, and maybe someone internal that did something strange. But in general, those are things you're going to want to investigate. So AWS S3 data, we use, Humio has a feature called bucket storage. So when you deploy in Google or AWS, you have the option to have your persistence layer actually be S3. So this is our operations cluster that we're looking at the metrics of. We're pulling in those S3 metrics that are important to us. And one thing that I wanted to point out by showing the S3 data is there are some metrics that are only updated once a day. So for instance, bucket storage size and the bucket number of objects are only updated once a day. That's why that graph looks very flat each day. So with that in mind, those are two metrics that you generally don't need to query every minute because they're only going to change once a day. So if you have thousands and thousands, or well, you can't have thousands of buckets. If you have hundreds of buckets or a lot of buckets, you generally only want to run these queries once a day. So maybe you have a different class of queries that run once or twice a day versus one that runs every 5 minutes. But other data for S3, like downloaded storage bytes and downloaded GET requests, are like a normal metric. They're always updating. So looking at the how we actually take that data and produce these graphs, this is what the query would actually look like. So we're pulling in that data via the Prometheus exporter. We're looking at the average. We're basically averaging out the byte size and giving me a span of 1 day because that data is at that resolution. If here's how you would actually create an alert based on this sort of data. I could have a bucket to monitor and say if the size of if the gigabyte size of that bucket over this length is less than 25, I want to send an alert. Maybe it's you're monitoring automated process or something like that. That's how you would actually create an alert out of this data. The last bit of data that I'm going to discuss is the managed streaming for Apache Kafka or MSK. This is actually a view of our some of our ops data. So we have an ops cluster that all of our other Kubernetes clusters send data to, including ones that aren't running Humio. And this is the Kafka setup behind that. And so there's a lot of different sources of data for this. There's not only Prometheus metrics data, there's data coming from Humio, and there's also data coming from enhanced metrics. So MSK has an option to enable enhanced metrics, which means that your Kafka servers are going to expose more information via Prometheus in particular. So information about topics being in sync, topics not out of sync, things like that. So this is how you bring all these disparate sources of data. So there's 3 or 4 different types of data going into this dashboard. Drill in, give you a little bit closer look as to what these actually look like. And then some of the queries that actually, this is one example of where we're using the CloudWatch log group. So one of the things that we like to know is why segments were deleted. And so we're actually pulling that out of the CloudWatch log group for the MSK server for our Ops1 cluster, and then piping that to a time chart and counting it. So these are really, really easy queries to write and integrate in, and all of this, and that data is coming from CloudWatch, as well as a bunch of other data coming from different data sources. So Prometheus, CloudWatch exporter, it's how we're getting a lot of that data, as well as from Humio itself, because Humio uses Kafka heavily. So one more thing I'd like to show real fast is what this looks like in a broader perspective. So once again, we're looking at one of our ops clusters, but we're taking it, we have a lot of different sources of data. So we have our disk usage and things like that. We also have, we use Nginx ingress controller in this cluster. So we have Nginx data coming out of our Nginx pods. In addition, we can see where we're actually looking at this total view of our interactions with S3, our NLB bids process, taking all this information, all this data from Humio, from AWS, and from our systems, and putting it all in these comprehensive dashboards. So you can't buy observability, but you can choose really good tools that help make your system more observable. You have to know what you want to observe and what things are important for you. And these are the things that are important for us, for instance. And so having all these disparate data sources is really, really important for us to have a total view of our systems and our operations. So just to add some tips, and there's one blank one. Using logs may be cheaper than metrics due to API calls. I think one of the things that I see a lot of people do is they'll get a new service, or they'll get into AWS and they'll find something that will find all their metrics and ship all their metrics somewhere. A lot of the metrics that you may have in your system in CloudWatch, you probably may never look at, or you may not care about those. So be cognizant of what metrics you want to use, because the more metric you use, the more API calls you're making. Those costs can add up really fast. Many metrics like S3 metrics don't update every minute, so don't pull them for every minute. So know about the metrics and how often they update and how much you should pull them. Using AWS organizations, if available for the product or service, is really, I think, a great approach. So you saw in our queries, we do run multiple accounts. I think that's a best practice approach that's really good and important. So if your service supports AWS organizations like GuardDuty or CloudTrail, it's much easier to run one Lambda that handles all of that from all of your organizations in each region than one per every account. So be mindful of the costs. One of the things that I didn't touch on that's interesting as well is you can have you can have CloudWatch events that are looking at your billing alerts. And you could send those to Humio. You could send all of your bill to Humio as well if you wanted to and actually digest it there. So it's important to look at your costs. So when you just set up these things, keep an eye on them for a week, 2 weeks, and make sure you're not running millions of API calls you didn't expect and get hit with a several $100 bill that you didn't expect because you clicked a button or something like that. So you can, I think that covers everything I was going to talk about. So, there's references at the end of the talk that we will pass around, but I think it's time for questions. And I see one question here. Do we have templates to connect to any service of Amazon? Not currently. There is some work going on that we should have finished up in the next several months for applications, which are bundles of dashboards, dashboards and parsers and alerts. And we're hoping that that provides that taking what I showed today and making it easier to install. So right now, building a lot of these dashboards is, we don't have many of them off the shelf. There are definitely community dashboards out there, but it's generally something you're developing yourself currently. So I think there were a few more questions submitted beforehand that I'll touch on. The first one being, how can we use Humio to access old logs stored in S3? The easiest way to do that, to my knowledge, is generally something like Vector that can read from S3 and process that. If this data is already in CloudWatch if this data is in CloudWatch logs and has log groups and log streams, you could use CloudWatch to Humio. But otherwise, Vector is generally a good choice. How does threat intelligence come to play in this architecture? So I actually hadn't had a lot of experience with GuardDuty in particular, and then when we started working on our SOC 2 Type 1 compliance, we needed a solution that, for intrusion detection and perimeter monitoring and internal monitoring, and GuardDuty really checked all those boxes. And gives you a really good idea of when people are port scanning you and things like that. So I think that one of the things that we didn't really show off about Humio that's really powerful today is the ability to search things. So I could take an IP address, for instance, and search across all of my data for that IP address. And so if that data is in GuardDuty or it's in CloudTrail, it's in my application logs, with one simple request across all of my data, I can find that suspect IP. So it's really powerful to have all of the data because it just provides more context, CloudTrail as well. Can I speak to what a migration from Elasticsearch to Humio looks like? Also, Loki looks interesting us, what makes Humio a better choice. So migrating from Elasticsearch to Humio is generally a matter of just changing the server that you're pointing to. I would say that the harder part, not the harder part, but the more time involved part, less than getting your data into Humio, is if you're relying on certain features from Kibana. You need to mine those queries. Don't necessarily, or those queries, you can't take your queries from Kibana and just put them in Humio. So you are going to need to rework how you do your queries and things like that. I agree, Loki looks super interesting if you're a Grafana shop, especially. I would say that at least from the people that I've spoken with, my impression is that Loki's really good from that Grafana context. It's less, maybe appropriate for discovery that maybe developers are doing for debugging. Where it really excels, at least in my impression so far, is just providing the context around my Grafana data. So when I see that bump in the Grafana graph, I can go see the logs associated with that server really easily, and search that server specific logs. But in terms of doing a search across all of my logs, I think that's where Humio maybe is more appropriate. It really depends on what you're needing to do. How does Humio help with monitoring microservices and distributed infrastructure? I would say when you start dealing with microservices, and this will touch on some of the other questions I have later around observability. But like I alluded to earlier, when we're running these microservices in a cloud environment, and I'm using Amazon services, so I'm using S3 and I'm using load balancers, I need that context, that data, alongside my microservices data in order to understand what's really going on in my system. So what Humio gives you the ability to do is take all these different pieces of data, that might be logs, that might be metrics, that might be events, application logs, application metrics, and have one view. So when I do have a problem, it's easy to diagnose. Microservices just up the complexity of things, and distributed infrastructure as well. Humio is a distributed system, so monitoring distributed systems is tricky. And so the more data you have and the more context you have around that data, it's easier to build the service level indicators and and the other service level, the service level indicators to understand what's important for your business. And that's when I talked earlier about how you can't buy observability. Observability is going to be different for everyone, and it depends on your business, and what you care about is different. And microservices just make that even harder. There's another question here. Can I manage logs from cloud and on-premise in the same dashboard at the same time? I don't quite understand in terms of, right, as it stands right now, if you would send all of your data to one Humio instance and use that Humio instance. Humio doesn't currently give the ability to look at data in other Humio clusters. So as long as the data is all going into the same Humio cluster, you're going to be able to view it. I think we have just a few more questions that are mostly around observability. So I'm gonna just kind of bring these three questions into maybe one. Well, can Humio help you to notify the service or application performance issues that may lead to customer-facing issues? Yes, so this is where the concept of service level indicators and service level obligations comes into play. So in general, monitoring for really simple things like the number of errors isn't generally what you want, because it depends on what that error is. And so you need to break down your errors into different classes of errors. And I think it's more, observability is more about the approach and what's important. If you're running a really popular website, you get a lot of 404s, and you get a lot of people trying weird things against your infrastructure. And so the concept of alerting on the number of 404s doesn't really make sense. You need to contextualize that for what's important about your business. Maybe the number of 403s to a certain endpoint are the most important thing you should be looking at. Is observability more about measuring what you decide is important in advance, or the ability to ask questions that you don't know up front about your system? I don't think it's not really a binary choice. It's not one or the other. I think when it comes to observability, you know, there are knowns, there are known things and unknown unknowns and known unknowns and things like that. So it's really both. I need the data to be able to make actionable decisions today about problems I know with my environment, but at the same time, if there's a problem that comes up that I'm not aware of or used to, you know, seeing, I need the data there in order to be able to diagnose that for the future. There's someone really prominent in observability who likes to say dashboards are just records of past failures, and that is the case in you know, in unknown world. One other question here: could you please spend more time on parsers? Could data be parsed? Can data be parsed after storing them? No. As it stands right now, Humio doesn't have the ability to reparse data. I could go into, let's see. Oh, I'm not sharing anymore. When it comes to parsers, you can get extremely complex. It really matters on how you want to send your data. Some people like to put all their data in one repository and would want to have a really complex parser. Other people put their data in multiple repositories, and then Humio gives the ability to have a view that brings together multiple repositories. There's really good documentation around parsers on our website. I would suggest you check it out. But to answer your original question, no, we cannot reparse data. Could observability metrics being then passed to third-party AI tool for further analysis? Yes. We don't currently offer any AI things, but the way that you would pass data to a third-party availability tool is well, so currently you can export queries to S3. So if you're running on-prem, you can enable this feature that when I run a query, I can actually save the results to S3 or GCS. So and you can do that in automated fashion with API or Humio Cloud and on-prem offer the ability to do what we call S3 archiving. So you can have all of the data that gets parsed and stored in Humio sent to an S3 or GCS bucket as well for other applications to read. And that's how you would actually go about doing that today. All right, so I think that covers all of our questions. Are there any further questions? I'll hang around for another minute or two. Don't see any further questions, so thank you all for attending. You can always you can try Humio for free, humio.com/getting started, and you could go do this today. You could go install the Lambda and start sending your CloudWatch logs to cloud.humio.com. I hope you check out the documentation if you have any questions. And then if you want further information, there's lots of different ways to contact us. So I will turn it back to Laura.
Thank you, Grant, and thank you for everyone for attending today's workshop. Just as a note, we'll be donating $10 for every attendee of this event to No Kid Hungry. They help provide 3 meals a day to healthy to kids in need. If you have any follow-up questions for us, please email us at events@humio.com. We will be sending out the recording of this presentation the next day or two to everybody. There'll be a very short survey that comes up at the end of this workshop. We'd appreciate your feedback. And everyone have a great day. Thank you for attending.